Notice here we have created, we have updated. At this time, we have the title, audit logs, a very interesting topic. Having full visibility on any change that happened to your entities. I always liked how Jira handled their audit logs for their ticket, like history, showing you exactly what happened to every field, by whom and when. And got me thinking, why not doing something similar? In this video, I'm going to show you how easy it is to create an enterprise-level audit logs similar to Jira with the help of SQL triggers, entity framework, and minimal APIs. So let's get started. First, let me show you what we are trying to implement, what we are trying to replicate, basically. This is Jira. And if you go to a ticket and change something, let me add, let's say, a label 2, and you go to the history tab here, you will notice that Jira keeps tracks on every change that you did. This is the new label, changing the priority, description, what was it and what it is now, and the time of that change, who did that change. This is very interesting and I like that. I want to implement something similar in my code. So to get started, let's first go to SQL Server. So I have now SQL Server Edge image running in Docker, and here, first I'm gonna create a new database. So create database, Jira like audit, and I'm going to use that. Now, let's create our first table. So let's say we have a table called tickets. So create table tickets, and our ticket will have a ticket ID, int, not null, primary key, and it is an identity column. So basically we will increment one by one. A ticket also can contain a title, which is varchar, let's say 250, not null. A ticket can have a description, varchar 1000, and it is nullable. Let's add few more. A status as int. I'm going to make it an integer because I'm gonna map it into an enum in entity framework. And let's add created at, created by, updated at, updated by for the history. Okay, so this is our table. Let's create. We created the table tickets. I'm gonna create a new table, which is tickets history, that contains the same properties, the same columns of this table, in addition to different more. So create table, let me copy everything here, and here, create tickets history. It has a ticket history ID. This is the primary key, and this is not. So ticket ID, and I'm going to add an operation as int because I'm going to map it also to an enum, not null, into the ticket history. Let's create this table as well. Perfect, created. So now we have a ticket table. What I'm trying to achieve here is whenever I insert any record to tickets table, or whenever I update, or when I delete, I need to insert a new record into the tickets history. And the way to do that without any intervention, without any manual work, is by using triggers. We can create a trigger into the table tickets on insert, update, delete, and triggers can be used to insert into the ticket history. So to create a trigger, create trigger, tr, start with tr underscore as a naming convention for my triggers, tickets, history, and then you specify the table on tickets. Our trigger is for, so for, insert, update, delete. So the way to catch whatever data has been added or edited or deleted into the tickets table, we can select from a table called deleted, or we have inserted. So we have deleted and we have inserted. And the thing is, we don't have an updated table that we can read from, but you can use the combination of inserted and deleted to catch if it is an insert, update, or delete. Let me show you how. First, check if we have a record in deleted. So select 0 from deleted. If we have a record in deleted, begin here. If we have a record in deleted and we have a record in inserted, it's an update request. So if exist, select 0 from inserted, begin, and so here, this is an update request. So if we select from inserted, we can get all the columns into that table, which is basically whatever we have in tickets. So I can do insert into tickets history, select. So this is an update and operation. I'm going to create later on an enum, which is 1 as inserted, 2 as updated, 3 as deleted, okay? 0 as undefined. So here operation is 2, insert into ticket history, select 2 as operation, and then star to get all the columns from inserted. That's it. And now else, begin, and so if we don't have a record in inserted, the else basically is operation F3. This is a delete request. And here we can put 3 star from deleted. And then if we don't have any record in deleted, it's basically a create request. So else, begin, and end. This is an insert request operation is 1. We put 1. Let's try to create that trigger. Success. Now let's try to test our trigger. So basically, if you do insert into tickets, so insert into tickets, all the columns, values, and let's have a title. This is my ticket. Description, I'm gonna put as null. Status, we will map it as an enum later on. So it's 1 as not started, created at, get EUTC date, created by, it's me, and null for the update. It's a create request. So if we insert, you'll notice that ticket history is null because we got something here incorrect, which is ticket history in the insert should be inserted. Well, that's a mistake. Let's alter the trigger. Success. Let's delete tickets. And then let's insert again. Notice here, one row affected and another row affected, which is the create and then the insert into the history. Now, if we select from history, you will notice ticket history, operation 3, on ticket ID 1, 3 is basically the deleted process when we deleted, and this is the create. Let me now try to update. So update ticket, set description equal, this is description, where ID equal to 2. And if you select ticket history, you will see a new record in history with operation 2 with the new description. We are going to use this history structure to get whatever changes that has been done on all the properties. Okay, perfect. We are done from SQL Server. Let's jump into Rider and create a new empty project. Okay, Jira like audit logs. It's an empty web API project. I'm going first to add few NuGet package for entity framework. So I'm going to use entity framework, SQL Server, and tools. Okay. Now I can create a new class. Let's wait for the restore to finish. Okay, now I'm gonna create our audit context. It is inheriting from DB context. Okay, we need to create our tables. So we have a class called ticket, ID, title, description. We need to create a status. So let's create an enum, public enum ticket status. Okay, so now I can add ticket status as a status. And the other field, created at, created by, updated at, updated by. So this is our table ticket. And simply here in the context, we can do public db set of ticket as tickets set ticket. I'm going to add a constructor to allow having more options. And now we need to add the ticket history. So you can create ticket history. You can create the same thing. Copy this one here, but I don't like having duplicates in my code. So because history is a ticket, basically, what we can do is we can create an abstract class, public abstract ticket base that contains all the fields. And our ticket will inherit from ticket base. History, same thing. So both ticket and ticket history will inherit from ticket base. And simply in ticket history, we need the primary key, which is the ticket history ID. So we have ticket history ID and we have the operation. So history operation, this is the enum operation. Let's also create the enum. I'm keeping everything in the same file for simplicity, but yeah, you can move your objects into different classes depending on the need. So public enum history operation. So we agreed, created is 1, updated is 2, deleted is 3. So history operation, typo here, history operation, and the ticket base. Now let's add another DB set for ticket history. I'm not gonna deal with the primary key, but you can create a configuration to specify every table what's the primary key. But for now, it's already in the database, so I'm gonna keep it simple. So go back to program.cs. Let's first add our context. Let's register our context. Builder.services.add DB context, which is audit context with options. So options.use SQL Server. We need the connection string, which is builder.configuration.get connection string. Let's call it default connection. Let's add the connection string and let's try to create our first endpoint. So map get tickets. I'm gonna inject the context, and here I'm gonna return context dot tickets like this. Dot tool is nothing fancy. So to test, I'm gonna add a new HTTP request file. I'm gonna call it tickets. Notice here tickets.http. Get the URL. This is the URL and tickets. This is our get request. So let me run the program. We run. We'll notice here we got one ticket in our database, which is the one that we created in SQL Server. Okay, I can create another endpoint to get the history. So tickets, let's get by ID. So ID as int, and here we have int ID, and we can tickets dot first or default t.id ticket ID equal ID. Okay, I'm returning the entity framework model as is. Yeah, well, it's a demo, but you should not return your database models into the API request. You need to create your own DTO and map them, maybe using Mapperly or any other mapping tool, or maybe manually. But for now, it's fine. Let's restart. Go to tickets. Let's create another one. Get get ticket by ID. So we have the ID 2 in the database. So let's run. This is a single item. Perfect. Now let's create another one, but to return the history. So tickets, ID, history. And here we can return ticket history dot where ticket ID as well ID. Restart. Let's add it also to the HTTP file. Ticket history. And here, history. If we run now, we should get an array of changes. So notice here, operation 1, ticket ID, and status 1. So the enum is not very known. It's like it doesn't mean anything. And to fix that, we can, with a simple change here in our program.cs, we can return the string representation of that enum. Basically, if you configure the HTTP JSON option, we can configure the converter of the serializer to use the string enum as a camel case. So this will support both getting the data from the API as a string, and also to send the request with the string, and it will be serialized to the enum itself. So let's run, go to the tickets.http, let's get the history. Notice here we are getting status open, operation updated, and we have created. Nice. This is so far very interesting thing that we have. I have an endpoint that can return a history for a ticket. Let's add 2 more endpoints, which is add and update. So I added a minimal API, HTTP post. When you post into ticket, again, I'm using the same model for now, it's fine. So we create a new model, created that will be set as the time, and the created by. You add it to entity framework, to the context, to the DB set, and you save. And I'm gonna return created. Okay, similar thing for put, injecting the ID and the ticket. If we don't find it, return not found, and update whatever needs to be updated. Notice I'm not updating created by or created at, only updated. Okay, and then we save. And I also added the endpoint into the HTTP file. So I have post and I have put. Okay, let's run. Now you need to make sure that before running the API, because it will fail, you need to add a small change into your context to support the triggers. So basically here, you override, let me close this one. You override on model creating, and you specify the entity ticket.toTable use SQL output call close to false. Notice here, why we are doing that? Because triggers will perform an output into the query. So basically you insert and the trigger will do something and return something else. We don't want entity framework to catch that. For that, we are going to do this one here. In .NET 7, this is added in .NET 8. In .NET 7, there is another option is to specify the trigger. So has trigger the name of the property, but we don't need it here. Okay, now let's run. Go to the HTTP file. Let's create a new ticket. Created. ID 3. Here, let's update. So notice here, incorrect title. Let's update. We got the title should be correct and it's now in progress. Now let's query the history by ID. So 3. Let's get the history. You will notice it's been created by John Smith. It's been updated by Jane Smith, and we have the date. So far, so good, but I like to add one extra step to this endpoint to have it give me the exactly change between a property and another property. So basically, giving me a list of changes similar to what we saw in Jira. So let's stop the code. First, I'm gonna move all the logic of endpoints into a new class. So Let me remove it from here, create a new class, endpoints. It's a static class, public void, map all endpoints. This I endpoint route builder endpoints, and let's rename this to endpoints. Okay, include whatever needs to be included. So I need to now in program.cs make sure to call map all endpoints. Okay, so now in my history query, I'm gonna do something different. First, let's get all the history for that ticket. So var history equal await dot toList async, and we need to make sure that the delegate is async. Perfect. So now we have the list of all history of that ticket. So what I'm trying to return is basically me minimize the noise. So I'm gonna create a new record, public record, history response. It has the user, so who did this history record? What is the history operation? So operation, the date, so date, time, date. And in addition, we will have a list of history records. So let's create another record, history record, with property, the previous value, and the current value. Okay, and here we can return a list of history records. Okay, so this is what we need to return. This is the structure that we're going to represent into this endpoint. So we got all the history. Now I'm gonna make sure to order the list. It will be ordered, but let's keep it. So order by the ticket history ID. So basically any new record is being added here. It will be ascending correctly. So got all the histories. Let's create our response, history response. It's a list of responses. So the first item, we only have one created. So if we do var created history equal history dot first or default, the operation equal to created. So let's get the first response, and we can add a new response with the user. So created history dot created by, the operation is created, the date is created history dot created at, and for the list of records, it's a created response, so we don't need to add anything. For the sake of nullability, let's do create history is not null. Okay, maybe you have added a record and something failed, so yeah, let's not fail our API here, and eventually we need to return the response. So we got all the created. We can do similar one for deleted. So the last one is deleted history. So the operation is deleted. Give me that. If it is not null, add the updated by. Let's change the user here to be nullable. And operation is deleted. Well, we can use deleted history dot operation, and here deleted history dot updated. Okay, and in the middle we need to combine both. We need to combine all the updated, but we need to group them by the updated time. So basically, if you update a ticket with HTTP pod, you change multiple properties, we need to show you one history response with multiple records. So let's say you change the title and description at the same time. We can have one record with an array of list of properties changed. Var updated history. So the updated history, it will consist of created and the updated, because we need to map the created with the second updated. So history.where, we can say x.operation not equal to deleted, simply like that. Okay, and then let's do a for loop into updated history.length.count. Let's do toList so we can have it as a list here. And now we can do var current equal. Make sure to start with I equal to 1. So this is the second item in the array. So we can skip this created. And current equal updated history of I, and previous equal updated history of I minus 1. So inside the loop, we have current and we have the previous. So I'm going to use reflection to get all the properties and start comparing them. So var properties equal type of ticket dot get properties. So we got all the properties, the property info array here, and then we can loop through the properties and start comparing. So for each property in properties, we can get the value. So current value equal property dot get value of current. Same thing for previous. Previous value equal property dot get value of previous. So we have the first, the current and the previous. Now we can check. So if equals current value with previous value, basically if they are not equal, we need to insert a new record. So here we are going to create a new history record as a list. So var history records equal, it's a list of history record. If they are not equal, we add a new history record. Property is .name. The previous value is previous value .toString, and the current value .toString. So whenever we don't have them equal, let's add them, and eventually we are going to create a new response. So responses.add new history response, the user, which is current.updated by current.operation, and we have current.updated at .value, and the list of records, so history records. Eventually we return the response. Okay, it's too much, but you will see what happened now when we run. So let's run the code. The API is running. Let's go to the endpoint and let's return the history. So get ticket history 3, let's run. Nice. Notice here we have created, we have updated. At this time, we have the title, previous value incorrect title, current value, the title should be correct, description, status. But well, we have updated at, updated by. These fields, we don't want them to be included in the history result. So to fix that, let's go to the context, let's go to the implementation here. Let's have an interface. So public interface, I audit history. It has basically this field here, and we can specify that ticket base implement I audit history. Okay. Now, if you go back to the endpoint here, when we started getting the properties using reflection, we can now get the audit properties using same thing, type of I audit history dot get properties, and then we can say properties equal properties dot where it's not inside the audit properties. So basically exclude all the properties that are found in the I audit history here dot to array. Okay. Now if we run again, go to the HTTP, let's run, you will notice that we removed the actual audit properties. And if we update, let's do another put here. So let's change the title only. Hello. Let's run. And if we query again the history, we added a new record. So James Smith updated this time only the title. Pretty cool. Okay. And here you have it. It was a long video, but I think it was worth it. Now you can create your own audit log feeling like an enterprise application. If you want to learn more about NuGet packages in local server, click here.